Good afternoon. This lesson today is going to be about the quadratic formula. And perhaps you're saying to yourself, oh, I know all about the quadratic formula. I love the quadratic formula. Well, we're going to take it a little bit further today because now we have a familiarity with the concept of complex numbers and imaginary numbers. And that allows us to look at a whole new set of solutions. So we are going to talk about the quadratic formula. We're also going to review what the discriminant is and talk about what does it mean when the discriminant is positive, when the discriminant is negative, or when the discriminant is a zero. So let's just quick review that the quadratic formula is good for finding solutions to an equation. Again, you cannot factor with the quadratic formula, but it's very handy for finding those realistic solutions that are not pretty numbers or whole numbers. It cannot be used to factor. We just said that. So don't try to factor. And the equation must be in standard form before we can start manipulating. And just to recall, standard form is ax squared plus bx plus c equals 0 because we're finding solutions. Solutions are x-intercepts that occur when the value of y is 0. And here it is. Here's the bad boy, the quadratic formula. I remember this by remembering that there was once a negative boy. He was all mixed up. He went to a radical party, but he was too square, so he lost out on 4 awesome chicks, and it was all over for him by 2 a.m. Ridiculous, I know, but hey, it works for me. All right, let's see how we use the quadratic formula. The first thing I like to do is identify what all the parts of my standard equation are. In this case, A is a 1. My B term is -2. I'm going to go ahead and write that over here and save myself a step. And then my C term is -24. Go ahead. There we go. So once I have identified what A, B, and C are, the rest becomes an exercise in substitution. I challenge you not to try putting all of this into your calculator all at once, because your calculator is only as smart as the numbers being typed into it. And the calculator does not respect order of operations. Actually, that's not true. It totally respects the order of operations. What it doesn't do is it doesn't understand your intention and will do exactly what you type in, even if that's not what you intended. Things to be careful of. The negative b is always the negative of whatever your b value is. If your b value starts off negative, then this will end up being a positive. The other thing to be aware of is a negative times a negative is always going to be a positive. So this first term under your radical will always be a positive number. The last thing to wonder about and to be careful of, because this is a very common mistake, is that if one of your A or C terms is negative, this second set of terms will turn into a positive. So be careful with that. Those are some common places where students make mistakes. From here, I'm just going to simplify. I'm going to say that this is really equal to +2 plus or minus the square root of, if I multiply it, -2 times -2 is +4. -24 times -4 is a +96. And in my denominator, I'm going to put a 2. Remember that this fraction bar is also a grouping symbol. This division by 2 is the very last step that you do. You cannot divide any of these parts by 2 until the very last step. Okay, so my next step is I'm going to add these two. So it becomes 2 plus or minus the square root of 100 over 2. And now that's about as simplified as I can get. I can take the square root of 100, and when I do that, I'll go ahead and write that out. 2 plus or minus 10 over 2. And now I need to break it up to find the two individual solutions and simplify. I'm going to break that expression up into 2 equations. One of my equations is going to contain the +10, and the other one is going to use the -10. Each of these can be simplified independently 12 divided by 2 gives me x equals 6. 2 minus 10 is negative 8. I'm going to do this out to the side so you don't get confused. Negative 8 divided by 2 is a negative 4. So those are my two solutions. Oh gosh, look at, I saved all my space here and didn't even need it. So my solutions are 6 and negative 4. If I were to graph these solutions, positive 6, negative 4, they would appear somewhere about around here. And my parabola is shaped from there. So that's what these two solutions represent. They are the places, the x-intercepts of a parabola, and that was the whole purpose of using this fella. All right, so that was a review of the quadratic formula and how it's used. I'm going to leave practicing that lovely thing to you. I want to move on and talk about the discriminant, because the discriminant can often tell us a lot about the graph of a quadratic function without us having to actually find the solutions. The discriminant is actually the part that's under the radical symbol, b squared minus 4ac. And we can use this to determine how many real solutions there are. This is a great table. You want to familiarize yourself with it. Let me say that again. You want to familiarize yourself with this table. It is much easier to know what your solution, or to figure out what your types of solutions you have by looking at the discriminant than it is to actually use the quadratic formula to go all the way to solutions to give you the same information. All right, so what does this lovely table say? It says that when A, B, and C of a quadratic equation written in standard form are rational numbers, and when the first term is not a zero term, then you can look at the discriminant to determine the number of solutions. So if all of this mumbo jumbo under your radical symbol turns out to be a number greater than 0, then you have two real rational roots, which is just like the example we finished solving. If it turns out that the b squared minus 4ac, when that comes out and it is greater than 0, but it is not a perfect square, then that means you have two irrational roots. Irrational root, folks, is just a non-terminating decimal, a fraction, something of that ilk. So you'll notice here, because our 100 was a perfect square under my discriminant, that is a perfect square. So that tells me that I have two real solutions and that they're rational numbers, they're whole numbers. Okay, so those are the first two cases, and that's when the number under the discriminant, or the number under the radical being the discriminant, is a positive number. If your discriminant, or the numbers when simplified under the radical symbol, come out to be 0, then that means there's one real solution, and that means that your parabola touches the x-axis in exactly one spot. And then lastly, this is one that we glossed over frequently in Algebra 1, but we can now work with because we understand complex numbers and imaginary numbers. If the discriminant turns out to be a negative number or less than 0, then that means that there are two complex roots. That means you can write the solutions as complex numbers. All right, that was a lot of talking. Let's do some examples so you can see what it means to look at the discriminant. Right, so on this first one, I'm going to do what I did before, and I am going to first write this in standard form. So I notice that if all my terms aren't on the same side, so I'm going to add 3 to both sides so that my equation is set equal to 0. I'm going to identify the A part, my B term, and my C term. And I'm going to go ahead and write out my discriminant. And there's really no fancy schmancy abbreviation for it, but the equation is b squared minus 4ac. And now I'm going to do my substitution. And when I do that, my B term, goodness, I almost made it. My B term is 5, my A term is 4, and my C term is 3. So if I simplify this, 5 squared is 25. -4 times -4, sorry, -4 times +4 is 16. 16 times 3 is 48. And when I simplify that one further step, I get -23. So that is my discriminant. If I look at the table above, I learned that because my discriminant is negative, that there are two complex solutions. That just means that my parabola never crosses the x-axis and might look something like that. So that's what happens when your discriminant is a negative number. Folks, lots easier than doing the full quadratic equation formula. All right, this one we're going to do. This one is already in standard form, so I'm going to identify my A term, my B term, and my C term. I'm going to substitute into my formula, which is b squared minus 4 times A times C. Bear with me while I did it again. I don't know. This should be -30. My apologies. This is the 9. Pay attention, Palmer. Okay, better. This is -30, which when squared gives me a big 900. 4 times 9 is 36. 36 times 25 also happens to be 900. So I'm going to when I simplify this, I get 0 for my discriminant, which means that I have one real solution. If I were to think of what that means graphically, that means that my parabola touches the x-axis in exactly one spot. One more, folks. For this one, I, again, need to put this in standard form. I'm going to do that by subtracting 1 from both sides. I'm going to identify my A, my B, and my C. I'm going to hope to heck that I can actually substitute correctly this time. B squared minus 4AC, where, look at me, I can be taught. It's a great line from Philatides in Hercules, if you're into Disney movies. Okay, -2 squared. Like I said, this first term will always be a positive. -4 times 6 is -24. -24 times -1 is a positive 24. This ends up simplifying to 28, which is my discriminant. It is not a perfect square, but it is positive. So this tells me that my rational roots, or my roots are going to be real and irrational. So there are two real, which means they don't contain imaginary numbers. They're irrational, which means that they will have to be described in a fractional form. Then they are roots or solutions. And graphically, it means there's two of them. They're just not going to be integer numbers or terminating fractions. Fractions don't terminate, terminating decimals. All right, folks, so that's how we use the discriminant. That's how we use the quadratic formula. And if you stay tuned in the next little video, I am going to show you how to use these to solve a real world problem involving Miss Taylor throwing Mr. Modesty's phone.